All right, welcome back to 9.8. In this video, I'm going to talk about how to use Cramer's rule for a 3x3 system. But before we can do that, we need to talk about how to find the determinant of a 3x3 matrix. So that's what we're going to do first. So to find the determinant of a 3x3 matrix, first we're going to augment our matrix a little bit. So this is our 3x3 matrix. So we're going to augment our matrix by adding column 1 and 2 again. So you have 1, 2, 3, 1, 2. So you're just repeating 1 and 2, and you'll see why we do that in a second. So I'm going to blow this up so that I can write on it. So finding the determinant of a 3x3 matrix, the first thing we're going to do is we're going to multiply this diagonal. So A1, B2, C3, plus we're going to multiply this diagonal, B1, C2, A3, plus we're going to multiply this diagonal. So we have plus, hold on. Oh no, don't want to do that. Okay, I'm just gonna go off the screen a little bit. Plus C1, A2, B3. Okay, so those are our first three diagonals. Then we're gonna go the other direction. We're gonna subtract now this diagonal. So that would be minus B1, A2, C3 minus this diagonal, A1, C2, B3 minus this diagonal, C1, B2, A3. So what we're looking at here, you kind of end up with this crosshatch thing going on. So multiplying the diagonal and adding in this direction, multiplying the diagonal and subtracting in this direction. In my high school, we called this the pineapple rule because you kind of end up with this pineapple looking thing when you're done. So we'll call this the pineapple rule for finding a determinant of a 3x3 matrix. So just remember that you're multiplying down the diagonals and you're adding when you're going from left to right, and you're subtracting when you're going from right to left, and it makes a pineapple. Okay, so now that we've done that, now we can, whoa, oopsies, haha. All right. Now we can look at Cramer's rule. Now that we've figured out how to find the determinant of a 3x3 matrix, now we can look at Cramer's rule. So I'm going to scroll down to the Cramer's rule example. Okay. So for Cramer's rule, I was looking for one of those nifty blue boxes, but didn't have one this time. So for Cramer's rule, if this is my 3x3 system, then again, I'm going to have the determinant of a specific X matrix over the general general coefficient matrix, and the determinant of the general coefficient matrix, and that's how I'm going to find X, and it's the same thing for Y and Z. So the bottom one, the denominator, again, is always going to be just the regular coefficient matrix, so A, B, C. For X, the top one is going to have the answer column, Y column, Z column, So no X column, right? So answer column, Y column, Z column. The Y matrix, it has the X column, the answer column, and the Z column. And the Z matrix has the X column, the Y column, and the answer column. So they always don't have the column of the particular variable that you're finding. So it has the other three columns, but not that one. And then you're going to be finding the determinant for each one of these. So let's look at this example. So if this is our example, if this is our system, then our regular matrix is going to look like this. Our X matrix, you see it has the answers, the Y coefficients, and the Z coefficients, and so on. So setting these up is probably one of the most complicated parts, because you're like, okay, what columns do I need? Where do they go? And trying to set those up. Then you're going to find the determinants of all four of these so that you can find your X, Y, and Z. So you're going to find the determinant. So I'm going to do an example of finding the determinant of this one. And then the process is the same for all of them, and they've already done that for us. But I'm gonna show you step by step the process with this matrix. So looking at that, I'm going to write out my matrix. I have 1, 3, 1, 1, -2, 3, -1, 1, -2, and then I'm going to rewrite the first column and the second column. And this is the matrix that I'm going to use to find my determinant. So I'm going to switch colors here so we don't confuse ourselves. And I'm going to find this diagonal. So I'm going to multiply that diagonal. So I have 1 times -2 times -2 is 4. Plus multiplying this diagonal, 1 times 1 times 1 is 1. Plus multiplying this diagonal. So I have 3 times 3 times -1. So that's -9. So I'm adding a -9. And then I'm going to subtract this diagonal. So I'm subtracting -6. So I'm adding 6. And then subtracting this diagonal. So I'm subtracting 3. And then I'm subtracting this diagonal. So I'm subtracting 2. And then I do all that addition and subtraction, and that will give me my determinant. So I have 4 plus 1 is 5, minus 9 is -4, plus 6 is 2, minus 3 is -1, minus 2 is -3. So my determinant is -3, and that's the determinant for my coefficient matrix. So that's going to be the denominator of every single one of these. So that's that -3. So then when you find the determinant of these three, you'll get -3, -9, and 6 respectively. And then you'll just do the division, and that will give you your X, Y, and Z. So again, I think the most complicated part of this is just setting it up and then getting used to finding the determinant. If you can get that, I think you'll be fine. And again, you don't need to memorize Cramer's rule. I'm fine if you look at the formula of where everything is supposed to be. So if you have this in front of you, I think you should be fine. Hope that helps, and I will see you in the next video.